G'day everyone, this is Peter Mamrell here with Millie's Flying Fish Thingo Part 5. Alright, so today we will be doing the final function test for our flying fish. And so the objective for this test is for our fish body to hold a predetermined angle while we have a fan blowing. And the angle will be negative 15 degrees for the first test and positive 15 degrees for the second test. But yeah, firstly, before we get into the test, just a little bit about the fish and our test setup. So you will notice my fish is looking a little bit different. I no longer have the Arduino and the power bank attached to the body of the fish. Yeah, I was just having so much trouble with the aerodynamics of this fish with the battery pack kind of sitting here in the middle that yeah, I just couldn't really get airflow to kind of travel around with the big lump of plastic there. So I've just kind of moved the Arduino and the battery bank down onto the floor. Secondly, I kind of had the USB cable attached to the laptop. And that kind of ran from down on the floor here to the power bank. And it was just too stiff. It was just kind of preventing the fish body from holding an angle. So what I've done is I've extended all our cables from the IMU, the servo and the laser module. And I've just ran them down here. They're nice and flexible. And so you can see the body just likes to hold its angle. You'll notice I've also reprinted the fish body. I've made the body a little bit taller and I've made the tail much longer. And you'll also notice I've lopped the nose off my fish. And so, yeah, the reason for that is just to improve the aerodynamics of the fish. And yeah, just getting rid of the nose just allows our airflow to cause drag only on areas that will get the fish rotating in the correct direction. Yeah, so secondly, the fans that I've been using just didn't have enough oomph to kind of get the fish moving. So yeah, I used a hairdryer, which I kind of just found was just directing airflow just in too thin of a airflow kind of volume. So yeah, that had enough power, just didn't have the width. I tried the old trusty 1991 pedestal fan, but that it had like a wide enough airflow pocket, but just didn't have enough power. So what I've done is I've decided to pull out my two-stroke 21.55 cc leaf blower, and as you can tell, it certainly is going to have enough power, and it's got this kind of funneled nose down the end here, which gives us the perfect kind of airflow width to get this fish moving. So yeah, I'm going to stop the video here and cut to the tests. Thank you. Okay, so here we have my test set up. As you can see, we're outside. We have the big boy leaf blower out the back, about 1 meter away from the fish body. And in the foreground here, we have the fish and the Arduino set up attached to the laptop. I just want to apologize about my poor photography skills here. I did my best to get the laptop with the body heading readout and the fish heading laser pointer in frame, but yeah, it's not great. Just some notes about other issues. So I found that my servo motor had a lot of chatter and vibration when trying to hold position. So my fish setup was pretty shaky throughout the tests. It didn't affect things too much, but just a note. Another thing was drift from the IMU. It was very severe. You'll notice that these tests only go for about a minute or so before the drift gets so severe that the heading starts to creep. But yeah, other than that, I had really good results and I'm really happy with my code and my outcome. Okay, so this is test 1 where we're trying to hold a positive 15 degrees heading. So yeah, I hit send to the Arduino and our body holds a 0 heading for 2 seconds, and then the fishtail instantly moves to a heading as to redirect the body towards the positive 15 degrees. And as you can see, the system is actually pretty damn good. we're able to hold a 15-degree heading really accurately. Yeah, so yeah, I was able to tune my P and ID values with a little bit of back and forth and get some pretty good results. You can see there's a very small amount of overshoot and undershoot, but overall the system is very good. And I will mention that it was quite a windy day, so there are crosswinds here, and the system is dynamically holding position despite these additional wind loads. Okay, so here's test 2. This time we're trying to hold a negative 15-degree heading. Yeah, so the body holds 0 heading for 2 seconds and then moves to correct. You can see there's a lot of hunting, a lot of overshoot and undershoot. In this video, the crosswinds were much stronger. But eventually, yeah, the system does find negative 15 degrees and holds it pretty well. However, yeah, it does kind of walk off again. But yeah, overall, not too bad. Yeah, I'm really happy with my whole system. Overall, really happy with my code. And yeah, I've learnt a great deal doing this project. So yeah, thank you.